Hi friends, welcome to PharmaGrid. So today we are going to discuss 5 more calculations. So starting with the first question, methyl salicylate liniment APF contains 25% volume by volume methyl salicylate. What is the weight of methyl salicylate in a 100 ml formulation? The density of methyl salicylate is given as 1.18 gram per ml. So in the question they have given that 25% volume by volume methyl salicylate, which means 25 ml is present in 100 ml. Here we need to calculate the weight of methyl salicylate in a 100 ml formulation and the density is given. Density is nothing but mass by volume. So this is a question of simple cross multiplication. Okay, so here the density is given, that is 1.18 gram is present in 1 ml. That is the density of methyl salicylate, and we need to find out the weight of 25 ml methyl salicylate. Let it be x gram. So therefore x is equal to cross multiply. So 1.18 into 25 divided by 1. So we will get it as 29.5 gram. So here the correct answer is option E, that is 29.5 gram, which is the weight of methyl salicylate. That is the weight of 25 ml methyl salicylate in a 100 ml formulation. Next question. How many milliliters of hydrochloric acid having strength 36.8% weight by weight, density 1.19 gram per ml are needed to prepare 4 liters of a 10% weight by volume dilute hydrochloric acid solution? So in this question, we need to prepare dilute hydrochloric acid solution from a strong hydrochloric acid solution. So we will solve this question from backwards. So here we need to prepare 4 liters of a 10% weight by volume dilute HCl. So percentage weight by volume means number of grams present in 100 ml of the solution. So firstly find out how much hydrochloric acid in 4000 ml. 4000 ml means 4 liters means 4000 ml. That is 4000 ml of 10% weight by volume hydrochloric acid. So 10% weight by volume means 10 gram present in 100 ml. So let it be x gram present in 4000 ml or 4 liters. Let x be the amount of hydrochloric acid present in 4 liters. Now find out x using cross multiplication. 4000 into 10 divided by 100, that is equal to 400 gram HCl. So this 400 gram is the amount of hydrochloric acid present in 4 liters. Now we can find out the weight of strong hydrochloric acid solution containing 400 gram HCl, and the strength of strong hydrochloric acid is given as 36.8% weight by weight. Okay, that is 36.8 gram hydrochloric acid is present in 100 gram strong hydrochloric acid solution. Okay, so this is the concentration of strong hydrochloric acid. Now let take it as Y. The weight of strong hydrochloric acid solution containing 400 gram HCl, take it as Y. Then find out the value of Y using cross multiplication, that is 400 into 100 divided by 36.8. So by cross multiplying we will get the answer as 1086.95 gram. So here we got the answer in gram. If we examine the options, we can see that all the options are in volume or expressed in ml. So we need to convert this gram into volume. So in order to convert this into volume, a clue is given. Okay, the density is given. Density is given as 1.19 gram per ml. We know that density is equal to mass by volume. So from this we can calculate the volume. So volume will be equal to mass by density. Mass we already know, that is 1086.95 divided by density. Density value is 1.19. So that is equal to 913.4 ml. So here the correct answer is option D, that is 913.4 ml. Next question. A saturated solution of a drug contains 120 gram of the drug in a total volume of 100 ml. The density of the solution is approximately 1.5 gram per ml. Express the concentration of the solution in terms of percentage weight by weight. Okay, so in this question, here the weight of the drug is 120 gram and the total volume is 100 ml. Density is given as 1.5 gram per ml. We need to express the concentration of the solution in terms of percentage weight by weight. So percentage weight by weight means gram in 100 gram. So firstly work out the weight of 100 ml of the saturated solution. We know that density is equal to mass by volume. So from this equation we can calculate the mass. Mass will be equal to density into volume. That is density we already know, that is 1.5 gram per ml multiplied by 100. 100 is the volume of the solution. So 1.5 into 100 we will get it as 150 gram, which is the weight of the saturated solution. Now we can calculate the percentage weight by weight of the drug. Percentage weight by weight of drug means gram in 100 gram. That is weight of the drug divided by weight of the product into 100. So weight of the drug we already know, which is 120 gram, and the weight of the product we have already calculated, which is 150 gram. So 120 gram divided by 150 gram all multiplied by 100, that is equal to 80 percentage weight by weight, which is the concentration expressed in percentage weight by weight. So here the correct answer is option C, that is 80 percentage. Question number 54. How much water would be needed to prepare 1000 ml of a saturated potassium iodide solution containing 100 gram potassium iodide per 100 ml of the solution? Density of saturated solution is equal to 1.7 gram per ml. So here we need to calculate the amount of water required to prepare 1000 ml of a saturated potassium iodide solution. So firstly, work out the amount of potassium iodide in 1000 ml of the saturated solution. So in the question they have given a clue, that is 100 gram potassium iodide is present in 100 ml of the solution. That is written here, that is 100 gram potassium iodide in 100 ml. So let it be x gram potassium iodide in 1000 ml. So find out x using cross multiplication. So x will be equal to 1000 gram potassium iodide. So this 1000 gram is the amount of potassium iodide in 1000 ml of the saturated solution. Now find out the weight of 1000 ml of the saturated solution. So here density is given as 1.7 gram per ml. Density means mass by volume. So mass will be equal to density into volume. Density we already know, which is 1.7 gram per ml, and the volume is 1000 ml. Okay, because we need to prepare here is 1000 ml. So 1.7 gram per ml into 1000 ml is equal to 1700 gram. So this 1700 gram is the weight of 1000 ml of the saturated solution. So now out of this 1700 gram, so this 1700 is the total weight of the saturated solution. So out of this 1700 gram, 1000 gram is potassium iodide. So here we have calculated the amount of potassium iodide. Amount of potassium iodide we got it as 1000 gram. So total out of this 1700, 1000 gram is potassium iodide. Therefore the rest must be water. So what they have asked in the question, we need to find out the amount of water required to prepare. So amount of water required will be equal to 1700 minus 1000, that is equal to 700 gram. 700 gram, that will be equal to 700 ml. This is because density of water is equal to 1 gram per ml. So 700 gram will be equal to 700 ml. Thus we got the answer as option D, that is 700 ml. Next one, what mass in gram of acetic acid is present in 100 ml of acetic acid having strength 33% weight by weight BP? Density of acetic acid BP is equal to 1.04 gram per ml. So in this question, firstly calculate the mass of 100 ml of acetic acid BP. Density they have given us 1.04 gram per ml. That is 1.04 gram is present in 1 ml. So let it be x gram present in 100 ml. So therefore x is equal to 1.04 into 100 divided by 1, that is equal to 104 gram acetic acid BP. Secondly, calculate the weight of acetic acid in 104 gram of acetic acid BP. So here the strength of acetic acid is given as 33% weight by weight. That is 33 gram acetic acid is present in 100 gram acetic acid BP. So let it be y gram acetic acid present in 104 gram acetic acid. So by cross multiplying, we can calculate the value of y. Y is equal to 33 into 104 divided by 100. That is equal to 34.3 gram. So here the correct answer is option A, that is 34.3 gram. So with this question, we have completed today's calculation series. Thank you everyone for watching this video. Please like, share and subscribe. Have a great day.